NENOMATICA, where mathematics meets YouTube excellence. Welcome! In this lesson, we'll build a strong, intuitive understanding of Newton's binomial theorem. Our focus will be the general term formula, which lets you jump straight to any term in a binomial expansion without expanding everything. The binomial theorem expands open parenthesis, a plus b close parenthesis to the n as a sum of terms. Each term has three parts: a binomial coefficient, a power of a, and a power of b. Let me show the compact formula now. We read this as the sum from k equals 0 to n of n choose k times a to the n minus k times b to the k. Let's also write the general term as t sub k plus 1. T sub k plus 1 equals n choose k times a to the n minus k times b to the k. For k equals 0, 1, up to n, notice the exponents of a go down as k increases, and the exponents of b go up. Why does the binomial coefficient appear? Think of open parenthesis, a plus b close parenthesis to the n as n copies of open parenthesis, a plus b close parenthesis multiplied together. From each copy, you choose either A or b. If a term has k copies of b, and the remaining n minus k copies of a, then how many ways can you choose which positions become b? Exactly n choose k. Let's visualize that with n equals 5 and k equals 2. We'll mark 2 positions as b, and the other 3 as a. No matter which 2 positions you choose, the product is a to the third times b squared, and the number of ways to choose those positions is 5 choose 2. Those binomial coefficients also line up in Pascal's triangle. Each number is the sum of the two above it. This quickly gives the coefficients of open parenthesis a plus b close parenthesis to the n for small n. Let's summarize the general term formula you can use right away. T sub k plus 1 equals n choose k times a to the n minus k times b to the k. You can jump to any term by choosing k. The exponents always add up to n. n minus k plus k equals n. Now, a worked example. Question: find the x cubed term in open parenthesis 2x minus 3 close parenthesis to the fifth. We'll identify a, b, and n. Here it equals 2x, b equals negative 3, and n equals 5. We want the exponent of x to be 3. The x power comes from a to the n minus k. So set n minus k equals 3. That gives k equals 2. Now apply the general term formula with k equals 2. T sub 3 equals 5 choose 2 times 2x to the third times negative 3 squared. Let's compute each part. 5 choose 2 is 10. 2x to the third is 8x cubed. Negative 3 squared is 9. Multiply. 10 times 8 times 9 equals 720. So the x cubed term is 720x cubed. A quick note: if b is negative, signs alternate according to the power k. Even k gives a positive contribution from b to the k. Odd k gives a negative 1. That's why our x cubed term here was positive. Recap. 1. The general term formula jumps straight to any term. T sub k plus 1 equals n choose k times a to the n minus k times b to the k. 2. The exponents of a and b add to n. 3. The coefficient is n choose k, which counts the ways to pick which factors contribute b. With this, you can handle binomial expansions efficiently and confidently. In this video, we will use the binomial theorem to find the value or values of x that make the third term in the expansion of left parenthesis x plus x to the log x right parenthesis to the fifth power equal 10 to the sixth. Let's write the problem and set our goal clearly. First, recall the general term of a binomial expansion. The k plus 1 term equals n choose k times a to the n minus k times b to the k. We'll apply this rule with a equals x, b equals x to the log x, and n equals 5. Now, apply the rule. Our expression is left parenthesis x plus x to the log x right parenthesis to the fifth. The third term means set k equal 2 because the third term is t sub 3, which equals t sub k plus 1 when k equals 2. So here, at equals x, b equals x to the log x, n equals 5, and k equals 2. Compute the third term. T3 equals 5 choose 2 times x to the 5 minus 2 times x to the log x squared. That is 10 times x cubed times x to the 2 log x, which equals 10 times x to the power 3 plus 2 log x. We are told this third term equals 10 to the 6th. Set 10 times x to the 3 plus 2 log x equal 10 to the 6th. Divide both sides by 10 to get x to the 3 plus 2 log x equals 10 to the 5th. Take common logarithm, base 10 of both sides. The left becomes 3 plus 2 log x, all times log x, and the right is 5. Quick challenge. Before we expand this fully, can you predict the quadratic equation in log x? Think, what if we let t equal log x? Let t equal log x. Then the equation is 2t squared plus 3t minus 5 equals 0. Solve the quadratic. The discriminant is 3 squared plus 4 times 2 times 5, which is 49. So t equals negative 3 plus or minus 7, all over 4. That gives t equals 1 or t equals negative 5 over 2. Now substitute back using t equals log x. If log x equals 1, then x equals 10. If log x equals negative 5 over 2, then x equals 10 to the negative 5 over 2, which is 1 over 100 times the square root of 10. Both values are positive, so they are valid for the logarithm. Final answer. The solutions for x are 10 and 1 over 100 square root 10. In this lesson, we'll solve the problem of finding the largest term in a binomial expansion. We'll use two ideas, the relation between consecutive terms and the middle term rules for even and odd exponents. Step 1. Relation between consecutive terms. In the expansion of open paren, a plus b close paren to the power n, the t sub k plus 1 term relates to t sub k by this ratio rule. We will also rewrite it as a ratio t sub k plus 1 over t sub k, which is the factor by which successive terms change. If we let x equal b over a, the ratio becomes open paren n minus k plus 1 over k close paren times x. This inequality tells us where the sequence of terms switches from growing to shrinking. Increase while the ratio is at least 1, and decrease when the ratio drops below 1. Step 2. Middle term rules. When it equals b, the ratio becomes n minus k plus 1 over k. For even n, there is a single middle term, and it is the largest one. For odd n, there are two middle terms, and they tie for largest. This matches what we know about the central binomial coefficients. Step 3. General largest term index. Starting from the ratio t sub k plus 1 over t sub k equals open paren n minus k plus 1 over k close paren times x, where x equals b over. Terms increase while that ratio is at least 1. Solving the inequality gives k less than or equal to open paren north plus 1 close paren times x over 1 plus x. Therefore, the index that gives the largest term is the floor of open paren north plus 1 close paren times b over plus b. The largest term is t sub, our plus 1 equals choose n, our a to the power n minus, our b to the power r. Quick challenge. Which term is the largest in a binomial expansion when the exponent n is given? Pause and think. Then we will apply the rule to a few examples. Example 1. I equals b and n is even. Consider open paren 1 plus 1 close paren to the power 8. Since it equals b, the largest term is the middle term. For n equals 8, that is t sub n over 2 plus 1, which is t sub 5. So the largest term is choose 8, 4 times 1 to the 4 times 1 to the 4. In this lesson, we will find the middle term of the binomial expression left parenthesis x minus 2 over x right parenthesis to the power 12. We'll go step by step using the binomial expansion idea and a clean simplification strategy. Step 1. Middle term rule for an even power. For n even, the middle term index is n over 2 plus 1. Here, n equals 12, so the middle term is the 7th term. Step 2. Using the rule with a equals x and b equals negative 2 over x, the 7th term becomes t7 equals binomial 12 choose 6 times x to the 6 times negative 2 over x to the 6. Step 3. Notice the exponent 6 is even, so negative 2 over x to the 6 becomes positive 2 to the 6 over x to the 6. Now multiply by x to the 6 and divide by x to the 6, which cancels to 1. So t7 simplifies to binomial 12 choose 6 times 2 to the 6. Step 4. Compute the binomial coefficient and the power. 12 choose 6 equals 12 factorial over 6 factorial times 6 factorial, which is 924. And 2 to the 6 is 64. Step 5. Multiply them together. T7 equals 924 times 64, which equals 59,136. That is the middle term, a constant term. In this lesson, we will solve a binomial expansion problem step by step. Consider the expression square root of 1 plus x minus square root of 1 minus x, all raised to the power n. We are told the coefficient of the third term is 28. We will find n, the total number of terms, the middle term, and write the fifth term explicitly. Key idea: in a binomial expansion, t sub r plus 1 has the binomial coefficient n choose r. So t sub 3 uses r equals 2, which gives the coefficient n choose 2. Since t sub 3 equals 28, we have n choose 2 equals 28. Next, write n choose 2 using factorials. That is n factorial over 2 factorial times n minus 2 factorial equals 28. Cancel the factorials to get n times n minus 1 over 2 equals 28. Multiply both sides by 2 to get n times n minus 1 equals 56. Now solve for n. Expand to n squared minus n minus 56 equals 0. Factor to get n minus 8 times n plus 7 equals 0. Since n is a non-negative integer in a binomial expansion, we take n equals 8. With n equal 8, the number of terms is n plus 1, which is 9. Because there are 9 terms, the middle term is the fifth term. To write t sub 5, use the general term for r from 0. T sub r plus 1 equals n choose r times square root of 1 plus x to the power n minus r times negative square root of 1 minus x to the power r. For the fifth term, r equals 4 and n equals 8. So t sub 5 equals 8 choose 4 times square root of 1 plus x to the fourth power times square root of 1 minus x to the fourth power times negative 1 to the fourth. Quick challenge. Can you simplify t sub 5 further? Before I reveal it, notice that raising a square root to the fourth power removes the root and squares the inside. Here is the simplification. 8 choose 4 equals 70, and square root of 1 plus x to the fourth times square root of 1 minus x to the fourth becomes 1 plus x squared times 1 minus x squared. Therefore, t sub 5 equals 70 times 1 minus x squared, all squared. If you prefer it expanded, that is 70 times 1 minus 2x squared plus x to the fourth. Summary: we use t sub 3 equals n choose 2 equals 28 to find n equals 8. In this video, we will find the largest coefficient in the expansion of open parenthesis 1 plus x close parenthesis to the 9th power. We will also use a symmetry rule for middle terms to do it quickly and intuitively. Here's the key rule that unlocks the problem. The binomial coefficients for n equals 9 are symmetric. K matches 9 minus k. Let's lay them out from k equals 0 to k equals 9. See how the n's pair up: 0 with 9, 1 with 8, and so on. For an odd exponent like 9, the two middle coefficients, k equals 4 and k equals 5, are equal and largest. Let's compute the common middle value. 9 choose 4 equals 9 factorial over 4 factorial times 5 factorial. That is 9 times 8 times 7 times 6 times 5 factorial, divided by 4 factorial times 5 factorial. The 5 factorial cancels, leaving 9 times 8 times 7 times 6 over 4 times 3 times 2 times 1. This simplifies to 3,024 over 24, which equals 126. So both middle coefficients are 126, and they are the largest in this row. Let's place 126 into the middle slots to make that visual. Therefore, the largest coefficient in the expansion of open parenthesis 1 plus x close parenthesis to the 9th is 126. Quick challenge. What is the coefficient of the third term in the expansion of open parenthesis 1 plus x close parenthesis to the 9th? The r plus 1th term has coefficient n choose r. So the third term corresponds to r equals 2. The coefficient is 9 choose 2, which equals 9 times 8 over 2 times 1 equals 36. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.